Solid fuel and liquid fuel rocket engine by Milan and Zidaan. There are two main types of rockets, solid fuel and liquid fuel. Solid fuel engines have been around for centuries. In the 20th century, liquid rocket engines came onto the scene as more efficient and high-powered alternatives and are now becoming used more and more frequently. See, we got a nice cube animation here.
Solid fuels consist of a fuel and oxidizer that are pre-mixed in a solid form. They're cheaper, simpler to use. The first solid fuel rockets were powered by gunpowder and used in warfare during the 13th century, and their max speed is 2,370 meters per second. Liquid fuels consist of a fuel and oxygen in a liquid state. They're more expensive and not as safe to use. The first liquid fuel rocket was invented and launched in 1926, and their speed range is 2,000 to 4,500 meters per second. Solid rockets are typically, they have higher thrust, less specific impulse, shorter burn times, and a higher mass than liquid rockets. And both types of rocket engines have very large altitude ranges.
Solid fuel rockets. Here is a diagram of a solid fuel rocket engine and how it works. And you know it's credible because it's from NASA.com. Solid rocket engines are used on air-to-air and air-to-ground missiles, model rockets, and as boosters for satellite launchers. In a solid rocket, the fuel and oxidizer are mixed together into a solid propellant, which is packed into a solid cylinder. A hole through the cylinder serves as a combustion chamber. When the mixture is ignited, combustion takes place on the surface of the propellant. As you can see on the diagram, a flame front is generated which burns into the mixture. Then the combustion produces great amounts of exhaust gas at a high temperature and high pressure. The amount of exhaust that is produced depends on the area of the flame front. And engine designers use a variety of hole shapes to control and change in thrust for a particular engine. The hot exhaust gas is passed through a nozzle which accelerates the flow. Thrust is then produced according to Newton's third law of motion. And here we have a similar diagram, but of a liquid fuel rocket engine, which is also from NASA. Liquid rocket engines are used on space shuttles to place humans in orbit, and many unmanned missiles to place satellites in orbit. And they were also used on several high-speed research aircrafts after World War II. In a liquid rocket, stored fuel and oxidizer are pumped into the combustion chamber, where they are mixed and burned. The combustion produces great amounts of exhaust gas at a high temperature and high pressure. The exhaust is passed through a nozzle, which accelerates the flow. They also produce thrust through Newton's third law of motion.
So solid fuel rockets are often used on missiles, model rockets, and as boosters on satellite launchers. And they are used on these because they do not need to be maneuvered as precisely as other rockets. Liquid fuel rockets are used on space shuttles, unmanned missiles, and high-speed research aircraft, and that's because these types of aircraft need to be maneuvered very carefully.
Very carefully. As you can see, the picture of the space shuttle on the bottom corner, it's got to be maneuvered carefully. And we'd like to thank everyone for giving us their generous time and watching this video to help support the cause of the Brown Boys Aerospace presentation. Here's a NASA astronaut saying thank you. Everyone I hope you have a nice day.